All right, welcome back to video 2, accumulation and net change. Guys, I want to first talk about some general strategies. We talked about this in the first video. We want to generally approximate these things as a Riemann sum before we write the integral. Once we have the Riemann sum, the integral is really easy, and we can evaluate it by either doing an antiderivative fundamental theorem of calculus, or we can plug it into our graphing calculator. Lots of ways to do that. But it's the Riemann sum that allows us to be thinking about the rectangles in this problem. So, quick example here. I've got initial velocity of a particle at 5 miles per hour. I have an acceleration as a function of time. And so I can't just multiply by time because that'll only tell me the acceleration at a given time. So how do I find the velocity change? Well, the velocity change is equal to the acceleration times the amount of time that I was at that acceleration. So when I look at this, I think, well, acceleration is the height of my function. The amount of time I was at that particular acceleration is delta t, which means that this will be the sum of my accelerations times my delta times, which means that my velocity change from 0 to 8 will be the integral from 0 to 8 of a of t dt. And I can quickly plug that into my graphing calculator, and I get that my velocity changed by 76.8 miles per hour during that 8-second interval, which means that my velocity at time 8 is 8 plus my initial 5 miles per hour, which is 81.8 miles per hour. What is my distance traveled for this exact same problem? So part B, distance traveled. Well, I know that my velocity, excuse me, my velocity function was 5 plus the integral from 0 to t of 2.4 u du. I chose u just arbitrarily. I don't want to use t because we don't want those to be the same. We don't want our indices and our variables to be the same. And so I know that this becomes 5 plus 1.2 t squared when I plug in, or when I undo that. And so what's my distance traveled? Well, from the previous video, I know that distance traveled equals the integral from 0 to t, in this case 8 seconds, of velocity with respect to time. Except that, remember, distance traveled, what do I need to have in here? I need to have absolute values, because otherwise I will get a displacement. And when I plug this into my calculator, I get 244.8 miles per hour seconds. Wait, what, you say? What does that supposed to mean? Well, my velocity is in miles per hour per second. My time is in seconds, and I am multiplying the two of them together, velocity times time, in order to get this. And so I'm going to need to do a quick conversion here where I recognize that 1 hour is 3,600 seconds. And what this then gives me is 0.068 miles, which is about 360 feet. All right, so go ahead and do exercise 9. Again, good thoughts on some things to watch out for here, which is our units. We really want to watch out for units when we're doing these things. And how do I remember this? Well, when I look at this, I remember miles per hour and seconds. So, all right. Exercise 9. Thanks for watching, and we'll be back with the next video.